We are ready to begin to study the reactivity of organic compounds, and the information on this page is going to serve as a roadmap to guide the journey. What you can see is that all organic reactions are going to fall into just one of 7 categories. And so like a roadmap, this gives us the big picture of where we are and where we're going. Just like a roadmap, we're going to be using it frequently throughout the remainder of the semester, and each time we encounter a new transformation, you'll see us refer to it. Like a roadmap, it's going to be of most value, or we'll understand it the best, really only at the end of our journey, at the end of the semester, because we've traveled the whole journey and we can see how the pieces all fit together. So rather than spend a lot of time right now going through each of these 7 different transformations, what's most important is that you realize that there is a finite number of different kinds of chemical reactions that organic compounds undergo, and that when we encounter a new reaction, we're going to be referring to this, and the details associated with that particular reaction will be important at that time. As you will soon discover, the conceptual framework that's going to help us understand these chemical transformations the most is what we call reaction mechanisms. So don't expect us to simply wind our way through this roadmap 1 through 7 in the order that's presented here. Instead, we're going to pick and choose our way through this in the way that makes sense from the standpoint of developing the conceptual framework of reaction mechanisms. We have already encountered the first of these transformations, the acid-base reaction, which we'll be referring to frequently as the proton transfer step. Throughout the semester, we'll continue to see acid-base transformations and the important role that they play in reaction mechanisms. Throughout the entire semester, we're going to encounter examples of organic oxidation and reduction reactions. And for right now, all I want you to recognize is that these can often be identified by a change in the number of carbon-hydrogen bonds. And I'll have more to say about that when we encounter some examples. Where we want to focus our attention, where we're heading to next, is the class of reactions that are known as substitution reactions. And quite simply, these are reactions in which we replace one group with another. Our focus initially is going to be on reactions of the substitution type in which carbon is going to be sp3, and we'll replace the carbon X bond on an sp3 carbon with a carbon Y bond, the same sp3 carbon. That's known as a substitution reaction, and that's where we're going to begin our study.